we would have labeled the angles a lot earlier and found the similar triangles earlier. But because we found this point E that looked delicious, we kind of went at it, and it turned out... I've seen that happen like a few times where I'm doing a problem with a group, and then we find a point that looks so useful, and then it turns out to completely be bait. Cough Iran TST. But it doesn't happen often. Usually if you find a lot of points, if you find a point with a lot of circles passing through it, then it's a good sign. But I don't know, man. Okay, N4. I have some expression. So, oh my god. So I'm gonna just start by writing the factorials. I think I have to start that way. So here's 2 to the k plus 1 factorial over 2 to the k factorial, 2 to the k factorial. And then you subtract off 2 to the k factorial, and then 2 to the k minus 1 factorial, 2 to the k minus 1 factorial. Okay, so right away there's a bunch of stuff that factors out. I guess you can't see my writing. So let's just factor it all out. So let's take the 2 to the k. Yeah, the left, okay, actually, what am I doing? So this is, oh, this is going to be so heavy on indices. Okay, and this is why I'm really scared to do this problem on stream. Which is why IMO this year didn't ask you to prove something specific. Mm. And then minus 1. A. Just figure out how to video yourself writing on paper. That's not a terrible idea, honestly. I might actually switch to document camera. But I don't know. I have to think about it. Okay, so the thing that's outside is actually just literally, okay, so I'm not even gonna... This is 2 to the k choose 2 to the k minus 1. I didn't actually need to do all that work. And that's the thing inside that's interesting. So on the bottom, I have the product of 2 to the k minus 1 plus 1, 2 to the k minus, so, you know, everything up to 2 to the k. All of this is squared, but we're not really scared of this guy because this guy on the bottom, I can just compute the v2 exactly. Heaven House Tour? Maybe someday, not this stream. I already wasted too much time on the G3. And then the guy on the top is the one that's interesting. So this is a 2 to the k plus 1, 2 to the k plus 2. This is 2 all the way up to 2 to the k plus 2 to the k. Minus 1. Okay, so this guy here, I actually don't know off my head what the v2 is. Is it just 1? I think this is v2 equal to 1. This should be computable, so I won't... It should be 1. It should be 1. Okay, and the v2 of this whole blob here is something. So there's a couple things I can do at this point. I can say it's computable, so I'll compute it later and just focus on the top. Or I can actually compute it so I know what I expect it to be, and maybe given my track record, I should take the free hint when I can. So, oh my god. Okay, here. Let me just use the big hammer. v2 of a factorial is equal to a minus the sum of the base 2 digits of a. Is that right? That's Legendre's formula. So, 2 to the k. This one is definitely 1 as a result. And then this one, it's twice of v2 2 to the k factorial minus v2 of 2 to the k minus 1 factorial. So according to the formula, this should be 2 to the k minus 2 to the k minus 1, and there's 2 minus 1 terms that cancel out. So apparently this is actually pretty big. It's equal to 2 to the k? Is that right? Did I mess that up? 5, let me check a case so I can 5, 6, 7, 8, 14. Okay, cool. So that means I can just focus on the top now. So want top to have v2 equal to 2 to the k plus the answer 3k and then plus 1 minus 1. Okay, so we strip away the stuff that doesn't really matter, and it boils down to the following. It's 2 to the k all plus 1, 2 to the k all plus 2, and then 2 to the k up to 2 to the k minus 1. We want this to equal 2 to the k plus 3k minus 1. The minus 1 on the top looks annoying. I agree it's annoying, but I think it's the point of the problem. Like, if there wasn't a minus 1 there, you could literally just, everything would be, like, just computable easily. So the minus 1 is there because of the minus 1 is not in the numerator. Wait, what? Did I? Oh! Sorry, okay. Ah, man. Oh, shoot. Okay, sorry. The minus 1 is not up there. I guess I would have noticed that really soon. Okay, that's a different story, yeah. This is the denominator. Oh, God. Okay, yeah. Oh, that's bad. That's actually bad. Yeah, then it's even worse. Minus, okay, so... Okay, so we want that. Is that actually what we're going after? Because if so, that's actually a really bulky expression. Oh no. Do I have to do this problem? Why did I pick this problem? Oh my god. Is that actually the thing that has the difference in it? I'm not a crazy person? Oh my god. Why is it... Why is there a typo on random AOPS post? What's the typo? Post it. Oh, I never noticed that. Okay, I'll go fix it. Okay. I'm actually surprised the V2 is that high though. It, like when you look at it, it doesn't look like it should. There isn't 2 to the. It's literally 2 to the 2 to the thing. Why is it that high? Well, I fixed it already. It used to say positive instead of positive. When will the stream end? I think after I do this problem, I'll stop doing math and take questions and then play StarCraft. I think that's the current plan. I don't think I have the energy to try the Taiwan problem right now. Although, honestly, I don't know if I have the energy to do this problem either. Oh my god. Oh no, it's such a big expression. So, you can simplify it. Can you simplify something like 2n choose n into sum of squares and n choose 2 and do that? 2n choose 2. Oh, you guys want me to use, will that be easier to work with? Because when I see this, I kind of want to expand the polynomial and see what happens, honestly, is my first instinct. Like, for example, when k equals 4, what you're looking at is, but x equals 2 to the k minus 1, and when k equals, sorry, when k equals 2, you have, so let me give things names. We're going to call the thing here, a, and I'm going to call, oops, oh shoot, uh-oh, a equals a. I'm going to call the thing inside the brackets b. Or, let me, yeah. I'll just call it b, and then if I need to refer to the thing inside, I'll call it square root b. So this is like x plus 1, x plus 2, x plus 3, x plus 4. And b is like equal to x plus 1, x plus 2. Sorry, this is 2, 2, 2, 2. Okay, so there is a bit of stuff that factors out. Right, because I can see the 2 to the k minus 1 plus 1 things factoring out. So a minus b in general will be equal to so there's a square root b, and then there's like a minus square root b, and there's like a power of 2. I guess it's like half the number of terms, so 2 to the k minus 1, and then times 2x plus 1, 2x plus 3 is to the k minus 1. Okay, so the aim, yeah, I can factor out the x plus 1, x plus 2 thing. You can compute the v2 of the square root b. It'll be something. Oh man, there's so much calculations. I'll worry about that later. So the thing is, how do I simplify the stuff that's inside? 1, 3. I wonder if knobs generate, because I feel like something is weird to me because the square root's just for notation. It's so a and b are like about the same, at least the same number of terms. Like, the problem is saying that the v2 should be like 2 to the k plus 3k minus 1. And it just doesn't look that big. Like right now, the way I have it written, it doesn't look like the v2 should be exponential. So I feel like I haven't written the expression in a way that's correct yet. So I'm gonna try the k equals, I'm gonna try to write out explicitly what it is for k equals 3. So for k equals 3, after I factor out the thing that I said, it's like a plus 1, a plus 3, a plus 5, a plus 7 times 2 to the, well, 2 squared, and then outside there's some stuff. Okay, so I guess the stuff that's outside will actually be close to, it'll have exponential v2 because it's the product of a bunch of stuff. What was that sound? And then the thing on the inside is 1, 2, 3, 4. This is assuming I haven't made a calculation error yet, which I'm actually really skeptical of because this doesn't look right. When I take it mod 8, it's not doing the right thing. You get something which is 4 mod 8 minus something which is 0 mod 8, and the v2 doesn't look anywhere near big enough. So what did I do wrong? Okay, I'm gonna just rewrite the whole k equals 3 case explicitly and see if I can figure out where I messed up. So for k equals 3, the numerator should be a plus 1, a plus 2, a plus 3, a plus 8 minus the square, which is 4 plus 1, 4 plus 2, 4 plus 3, 4 plus 4, all squared. And the v2 is supposed to be equal to 16. Okay, so then again, as I said, we start by factoring out the... I'm starting to run out of space. Okay. Can't get it much larger than that. Okay, is that right? Apparently the v2 is supposed to be equal to 16, which feels kind of high. But I'm gonna roll with it and see what happens. So 10, 12, okay, so this actually should be a 4. That's already a mistake. And 10, 2, 3, 4. So if the 5, 6, 7, 8 factors out, that's the part we don't really care about. There's a 2 to the 4 here, and then the stuff that remains is a plus 1, a plus 3, a plus 5, a plus 7. So as some of you can tell, I really like doing things concretely because I'm not smart enough to do things abstractly at first. Okay, so that looks a lot more plausible now because the... Okay, so in the general expression, where did I mess up? Notes... I see, okay, this one should be 2 to the 2 to the 2 to the k minus 1. That looks more like it. Okay, and so this guy, the guy outside has v2 equal again to, should be 2 to the k, right? So this part here, in general, has 2 equals 2 to the k. We computed that already. Wait, is it 2 to the k? Half that, 2 to the k minus 1. So, in general, we want... Okay, we will... Okay, so we want this guy to have v2 equal to... Okay, so hopefully I haven't messed up yet, and I can... The expressions never fit on one line now, huh? You fixed your clock. Yeah, it's actually a script now. Before I was doing something much more stupid, but now it should correctly display the time. It's not off by 50 seconds. Yeah. Okay, so where am I? What is this and what is it doing? Okay, so this is what the k equals 3 example looks like. Oh my god. Alright, I'm gonna quickly punch the giant number into Wolfram Alpha to make sure I haven't screwed up the calculation yet, because otherwise this will be really boring. Watching me mess up repeatedly. So according to my prediction, the V2 should be 12. Yes, okay, that looks right. So that's what we're stuck with. So, okay. Long story short, I boiled away all the stuff with the factorials, and this is what we're left with. Remains. So here, x is 2 to the k minus 1, then yeah, I want this guy. And both of these are polynomials with 2 to the... Both of these are polynomials with 2 to the k minus 1 terms. Okay, so... Yeah, it's actually easier to look at the concrete example than the one with all the x's. Let me write down the target on the board here too. Plus 3k minus 1. Yeah, so in the red braces, I want that v2 to be exactly that number. Okay, so what do I do? It's weird to me that the 2 is on the term on the left. It seems like the left one is just way bigger than the right one. Yeah, why is the left one so much larger? It's like they're not even close. It's already skipping by 2. What's the cool formatting stuff you're doing? It's an alert block in Beamer. So in Beamer the code says alert block. like that. Okay, so okay, well here's the thing I can think about. So for k at least 2, okay. So we only need the big expression modulo 2 to the k 2 to the 2 to the k minus 1 plus 3k. Wow, that's a mouthful. So that means this part here, you can take mod 2 to the 3k and it'll be okay. So that means I can sort of take that thing and expand it, and everything that's higher than cubic will actually vanish. That will actually make my life much, much easier. So let's let y equals 2x plus 1, or sorry, y equals 2x, and y plus 1, y plus 3, dot dot dot, y plus 2 to the k minus 1. I'm allowed to take this thing mod y cubed. And the v2 of that won't change, if assuming the problem is correct. Must be 1. I don't know exactly what it is, honestly. It'll be something. We'll find out in a moment. I don't know if it'll be 1 or something nicer than that. But okay, so the constant term is 1 times 3 times, so it's just 2 to the k minus 1 double factorial. Is there a reason it has to be 1? Because the point is it'll be something, and then it will like cancel out some other stuff that's in here, is the hope. We'll see if it actually happens, but no. Okay, so okay, I'm just gonna write 2 to the k minus 1 double factorial because that hit expression is too hideous to use. 1/3. Okay, so this does actually feel pretty Wolstenholme, you know. I can see why people were saying Wolstenholme earlier. And then the other one is times y squared. Okay, so the other one is, okay, let me make sure I get this right. The square of this dude minus the sum of the, oh my lord, the squares? Okay, so it didn't fit again. Oh my god. Alright, what is this garbage? Yeah, it really looks like the Wolstenholme thing, but... Okay, so this one is definitely divisible by 2 to the k, right? The one here. This one just goes away. 1 over 1. It will be 0 mod y. I'm trying to see if it's clearly 0 mod y squared, which is what I need to kill it off completely. Also, the sum of squares, I can't tell whether or not it's 0 mod y by looking at it, although I'm not... I want the y squared term to go away. I really hope the y squared one at least goes away, but I'm not 100%. I think the y squared one should go away. So this one is definitely 0, because you can pair up the terms, so it will vanish. As for the other thing, okay, so this, the big ugly guy here, Okay. I need more space. LaTeX, don't fail me. Okay, so this one's definitely 0. This one should be 0 as well for k at least something, because mod y, this will be a sum of squares. So it'll be the sum of squares of things up to y over 2 times 2 or something like that. Yeah, so like William said. And because sums of... Actually, that's kind of dicey. For a moment I thought it was just straight sum, but it is actually sum of squares. Hmm. Yeah, actually that is a little... So if k equals 3, it's like 1 plus 9 plus 25 plus 49, which is not 0. Damn it. Alright. Alright, I tried. So I actually want... What I'm hoping for is a formula for the sum of... Okay, let me first get rid of the really big thing that's in the way. Okay, fine. Meanwhile, this guy actually is the same sort of story, right? Because if I pair up the terms, it will be 2 to the k times 1 over 1 squared. And this time the squares only go halfway. They go up to 2 to the k minus 1 squared. Oh my god. One squared, 2. Okay, so 2 to the k minus 1, all minus 1 squared. Let me make sure I didn't mess that up. Right, because I'm taking... Okay, cool. Cool. Alright, so in summary, this whole thing, mod y cubed, so I factor 2 to the k minus 1 double factorial, and it's equal to like 1 minus, I guess it's like... Can you please tell me they cancel out? Did I flip a sign? No, I didn't. They're just different. Also, the other one is twice that. Really? Oh, that's really lame. Don't the 2 to the k minus 1 double factorial terms disappear? Oh, good point. They should... No, they... Wait, what? Okay, it's a little weird because we're working on... Like, for example, in 8, 2 to the k minus 1 double factorial 1357 is actually minus 1. It's true, everything is an... Actually, it's just always minus 1. You're right. Okay, minus. So minus 1 minus... And then plus y squared times this horrendous thing, which I was hoping would cancel itself out, but apparently didn't. I really hope I just made an arithmetic error and it should cancel itself out, but I don't see it doing that. That's y squared. So I ended up with this, which, I don't know, seems really stupid. Okay, so you guys are telling me I should just be able to compute the sum of squares. Fine, okay, we'll try it. So the sum of squares, okay, at this point I'm going to expand this thing to, technology is amazing, right? Okay, so the sum of squares thing mod y is we're looking at the sum of 1 squared plus 3 squared plus 2 to the, if essentially we're trying to compute this number, give or take factors of 2. And according to the sum of squares formula, this is equal to the sum of squares up to y minus the even ones. So 4, 1 plus y over 2 squared. And so if I apply the sum of squares, y plus 1, 2y plus 1 over 6 minus 4 times y halves plus 1, 2y halves plus 1, all over 6. Um, wait, stop. It's just 2n plus 1, choose 3, is it? Oh, okay. Thanks for the tip. I'll take your word for it. 2y plus 1, choose 3. Okay, so, well, okay. I actually better write it out in the expanded form. Y, 2y plus 1, 2y minus 1 over 3. Uh, oh, it's y plus 1? Okay. Okay, so that's fine. In that case, that's pretty good actually, because at least there's this factor of y here. This was the main one. What we're actually looking at is this guy is half of it, and then the 3 cancels out. So I think in theory, this actually will tell us it'll about be like y cubed over 2, right? Evan, please. Um, oh, I see. You're saying there should be a 6 here. Oh, right, because you told me it was. Okay, fine. Um, oh, that's less good actually. Because this one is, oh, did I really? This is all Otis. There's a lot of Otis people here because, see, normally I just post on AOPS being like, uh, there's a Twitch stream, come watch me fumble shortlist problems, and then people would actually show up. But apparently I'm not supposed to do that, so now I just advertise to my kids. uh, bonk. Okay, so I hope I did that right. I was really hoping that sum of squares would cancel out because it looked like there was a chance that was going to be what happened, but no luck. Uh, I don't know. I think they like didn't. I think the administrators didn't want just like everyone advertising everything in CNP because right now there's just so much stuff. Everyone's doing stuff. So I think if people just started advertising, the CNP forum would just literally be a list of like various coronavirus inspired activities. So they said they wanted to have a different way of organizing these announcements, but I haven't figured out. I don't think they've told us what it is yet. Um, something's wrong. 56. So the big expression is odd. Wait, I feel like something is wrong here. Like this isn't doing what it really should. So when I expanded this y plus one, this one I'm not silly, right? Where the 1 minus... It's the double factorial times 2 to the k 1 squared. Yeah, that part, this one's correct. This one I said something was... I dropped a factor of 2, I think. Did I drop a factor of 2 here? Because this was originally the sum of the whole thing squared, which disappeared, minus this thing, and then times a 1/2. I think I dropped a factor of 2 here. I think there should be a half in front of this left. You flip the sign, 1 over a plus minus y over a squared. Yeah, that's this minus sign here, right? But the other one, yeah, this one was actually the pairwise and then 1/2. That's 1 over 1 squared minus the sum of squares, and then okay. So this is whatever this monstrosity is. This one is twice and then half, so that should just cancel. So I think this 3 should be a 2, which is better for us, because then it cancels out the 2 from... Actually, this is all really sketchy because I have these halves floating around everywhere. But see, here's the problem I'm having, which is that when I plug in k equals 3, like, let's try k equals 3 to debug, right? Then it's like 8 times... We're looking at 9 times 11 times 13 times 15 mod 512. And if I compute this number, I don't think it's going to match the things we're getting. So 9 times 11 times 13 is 1287 times 15. And I'll take mod 512, which is 263 times 15. And this is 3945. And that's like 361. MathCounts represent. Yeah, so that's actually really bad because it's like our calculations that I've been doing suggest that the answer should be like one less than like something that's really divisible by 2, and it's definitely not. It definitely isn't. Like, so I definitely messed something up, but I can't tell what. Hmm. Oh Lord. Yeah, small cases are so good. Oh wait, okay. I think the problem is that the 2k minus 1 double factorial is not minus 1. It's actually just some double factorial. Because we're taking mod y cubed, so you actually have to keep it double factorial. Okay, so let's keep the double factorial. Did the music stop? Okay, music back on. Okay, so right. I don't think the sum of the reciprocals from more y. So the reason we can replace the squares is because, let's say, these expressions, because of the things that are being multiplied on them, this one is y squared, this one's also, I guess, y squared over 2. This one I'm going to have to think a little more about, but I think this is correct. And what's happening is the inside expressions are being taken mod y. So the implicit claim is that 1 over y1 squared plus all the way, let's say up to 2 to the k minus 1 squared is like something something mod y. And what happens is you can actually, when you do this, you can actually take the inverses, I think. Because you get like inverses mod y. Okay, so I believe what we've gotten is that this is it again, and that matches my small case. Yeah, the double factorial, I can't get rid of it because this one is actually mod y cubed, but this one is 1 plus y cubed all over 2. I think that should be correct. 105. Yeah, 105. Yeah, that matches up now. Because of that. There's a bit of delicacy with this 1/2 that I'm going to put off until... I'm probably just not going to do it on stream, honestly. I think I want to try to wrap this up soon. But yeah, small cases are so good. It's how you debug your work. Can we just say it's odd? Which thing? The big expression. Which big expression? Actual question, which big expression? I think every expression on the board is big. Both. I'm not sure what you mean. Let me get back to that in a moment. I think we should be almost done now, because what we did is we computed the really big thing. What is both dots? Okay, I'll write out one more term for each of these dots so you can see what's going on. But in each case, it's sum of odd things. Two x plus 1 is odd. I don't think that's enough unless I'm missing something. Anyways, okay, so we now know this thing exactly mod 2 to the k minus 1 plus 3k. So all that remains is to compute this. This should be reasonable. So yeah, I'm hoping that I should just get the same double factorial. Actually, no, this doesn't look very reasonable. This is 2 to the k. I need a lot of 2's out of here. I mean, you can compute the number of 2's exactly. We've done it like 3 times now. The number of 2's is exactly 2 to the k minus 1. Wait a minute. Yeah, 2 to the k minus 1. And then this will be some odd. But I need to be a little finer about what that odd number is. So let's write it out. X plus 1, x plus 3. Oh, this expression is a lot worse than I thought it would be. Shoot. Oh, geez. Actually, that's really bad. Yay, nay, yay. So, I mean, again, the same thing happens where I only need to take it, once I factor out the 2's, I only need to worry about it mod, things. But, ooh, that's not good. Okay, I'm going to, shoot. That's not what I meant to do. Ooh, oof. That's really bad. Oh, no, no, it's fine, it's fine, sorry. It's just the double factorial. You get it's the bijection thingy. 4, 5, 6. Okay, yeah, because when you look at the example, let me put the example up momentarily again. So it's like 5, 6, 7, 8. I have this range of numbers, and I squeeze out all the 2's, and it's like 1, 3, 5, 7. So I think it's literally 2 to the k minus 1 double factorial. Like this is actually an equality, I think. You pull out all the 2's, and then every number 5, 6, 7, 8 will land in 1 of 1, 3, 5, 7 once I strip out all the 2's. And that will happen in general. It's this weird bijection thing. It's like for every odd number, there's exactly 1 power of 2 to multiply it on to get the right interval. So this is here. And then finally, subtract. And when we subtract, we get something which is y halves mod y cubed. Or y cubed over 2 mod y cubed. And this completes the proof. Oh no, we did it. We did it. This was not that bad actually. I didn't take too many false leads this time. Jeez. This is going on the formulas unit for those of you that know what that means. Yeah, so the part that I have to be delicate about is this factor of 1/2 I didn't justify properly. But I think it's okay by v2 arguments. I think what you claim is that this whole term no, that's not quite right either. Yeah, that's the part that I actually need to be careful about. It looks like I know what you know. I'm not thinking. Okay, that was not as bad as I thought though. For a moment I got really scared because I was like, the powers of 2 are just doing everything, and I'm like, what is that? But then I was like, wait, it's just double factorial, so amazing. Whew. What an adventure.